Hey shooters, my name is Bryce Bergen. I'm the founder and lead instructor here at Long Range Shooters of Utah. In this video, I'll be walking you through step by step how to set up and utilize the Shooter Ballistics app, which is the app that we teach and use in our 2-day intro to long range shooting courses. If you're interested in getting into the sport or just want to hone your skills, be sure to check out our website at longrangeShootersofUtah.com and check out our class schedule. Also, subscribe to our YouTube channel and follow us on Instagram and Facebook, where we post hundreds of videos about long-range shooting, including gear reviews and tutorials. Before we get started, I want to address one common question that we get from students and prospective students, and that is, why do you guys teach the Shooter Ballistics app? And the answer is simplicity. It's got a very linear format. You select your rifle profile, your ammo profile, pull in your weather data, select your target information, hit calculate, and you get really great accurate data. And it's also only $9.99. So it's very easy to teach, it's very easy to learn, and it provides a really great experience for our students. And that's why we use the Shooter Ballistics app. That doesn't mean that any of the apps are better or worse. They each have their pros and cons, but this is a great first app to get started with. And this video will show you exactly how to use it and how to set it up. The next question we often get is, I'm coming out to your class, but I don't have a rifle. I'm renting one of your rifles for the class, so how can I set up the Ballistics app? That's very easy. All the information that I'm going to be using in today's video is based off our rental rifles. I have one of those examples right here. All of our rental rifles are 6.5 Creedmoor, and they're all going to be very, very similar. They're all going to have the same optic and generally the same configuration, and you'll use the same ammo. Each one will differ just slightly on things like sight height, which is a measurement from the middle of the barrel to the middle of the scope, but all that information is written on this yellow piece of tape that's on the top of every one of our rental rifles. So if you follow all the information in today's video to the T and set it up exactly like I do today, that will be about 95% accurate to what your rental rifle will be when you get to class. Anything else will be made up for right here on this piece of tape, including the sight height. You'll also have the opportunity in class to zero the gun, get a new muzzle velocity, and update that information accordingly so it's as accurate as you can possibly get. Without any further ado, let's go ahead and dive into how to set up the Shooter Ballistics app. All right, the first thing we need to do is go to the App Store and search for Shooter Ballistics. The icon for the app is this blue and white target with the orange dot in the middle. It should be priced at $9.99, and it should look something like this. Go ahead and open the app. The first screen we'll come to is the home screen, but before we get started there, we'll want to click on this gear icon in the top left-hand corner to configure our settings. The first option we have is whether we want the theme of the app to match our operating system, be a light mode or be a dark mode. I personally prefer the dark mode. The next option is the default calc display, meaning when you hit calculate in the app, which of the 3 display options would you like to see first? We're going to leave ours as solution, but we will describe the pros and cons of each of these later on in the video. The next section is units of measurement, the first one being distance, and you have the choice between yards and meters. If you're taking our class, be sure to select yards. The next 2 sections have to do with atmospheric units. Both of these we'll want to leave as imperial, but you can change the metric if you're overseas. The last option here is wind angle unit. You have the option of using either degrees as if on a compass or the clock method. We found in the years of teaching our classes that far more people find the clock method to be more intuitive and easier, so we'd recommend using that. To give you an example, if we had a right to left blowing wind, that would be described as a 3 o'clock wind, meaning it's originating from 3 o'clock. Whereas if it was described in terms of degrees, that would be a 90-degree wind. Again, we find far more people find the clock method to be easier, so go ahead and select that. The next section is input options. By default, this will be turned off, and in that state, each time you open the app, it's going to clear out your weather data, and it will deselect your rifle and deselect your ammo profile, and also any information you put in about your target the last time you used the app. So you're effectively starting from scratch, or fresh. If you turn on Save Last Inputs, which I like to do, each time I open the app, it will retain all the information that I had the last time I used the app. So the rifle that I used will still be selected, the ammunition, the target data, and the weather data. So if I were going to be shooting on Saturday and I want to go back on Sunday or Monday and review what I had on that day as far as weather and my drop chart, if I have this turned on, I'll be able to do that. So I prefer to leave Save Last Inputs turned on. The next option is using density altitude instead of the standard weather data points of pressure, altitude, temperature, and humidity. We recommend leaving this turned off because density altitude can have some error. Let me explain. Density altitude is a single number used to describe air density, and it combines altitude, temperature, pressure, and humidity into one value. In some circumstances, you can have two very different environmental conditions that have the same density altitude. For example, a shooting range at 6,000 feet of elevation at 30 degrees Fahrenheit can have roughly the same density altitude as a shooting range at sea level at 95 degrees Fahrenheit. Even though the density altitude number is the same, the bullet does not behave exactly the same in those two environments. This can introduce some error at longer distances. Density altitude is generally fine for short and mid-range shooting, but if you want the most accurate ballistic solution possible, we're going to leave density altitude turned off and instead use the individual environmental inputs directly for altitude, temperature, pressure, and humidity. When it comes to pressure, you have the option later on in the app of choosing barometric pressure and altitude, or using station pressure, also known as absolute pressure. Barometric pressure is the pressure at sea level, and then they correct it based on the altitude. So you have to have both numbers, altitude and barometric pressure. If you use station pressure, also known as absolute pressure, you'll need to pull that from a Kestrel or from a weather flow weather device. That is going to be the actual pressure of the air where you stand, and that also will be a little bit more accurate than the density or than the barometric pressure would be. Again, we'll talk about that extensively in class, but that is an option within the app that you'll be able to choose later. The next option here is whether we want the precision of our muzzle velocity to be just down to the whole number or to go to the tenths. Let's go ahead and leave it as integer or whole numbers. Atmospheric acquisition. We have three options to pull in the weather into the app. The first one is called the weather station and is simply going to use our GPS coordinates to pull from the internet from the closest weather station to where we stand. You need to keep in mind that this could be a mile away, it could be 100 miles away. Here in the settings, we have the option of choosing which data inputs we want to have pulled in from that weather station. And for the most part, you can leave all of these turned on. One might argue that pulling in the wind speed and wind angle is probably not the best idea, simply because that weather station could be a long ways away, and therefore the wind speed and wind angle is probably not terribly accurate. So I'll leave that up to you, but for our purposes, let's leave all of these turned on. The next two options are the Kestrel and the weather flow. They both look very similar. Both of these are physical devices that you would have to purchase and have with you in order to pull in the actual weather data, and then it would simply send that data via Bluetooth to your Shooter app here. This is simply choosing what data you want to pull from those devices if you were to connect them via Bluetooth. And the same goes for the weather flow. It's similar information. The next section is our shot solution. This is one of the three display options that you have when you hit calculate, and so this section is simply defining the settings for that display. There are two options. You can choose which one you want to see as a default between the advanced mode and the field mode. You'll also be able to change these by touching the ellipses button, the three little dots in the top right hand corner when you're on the solution page. You can toggle between field and advanced. For right now, let's go ahead and leave it as advanced. The next option here is whether you want to use plus or minus for up and down and left and right, or if you want to just use up, down, left, and right. I can't think of any reason why you'd want to change up, down for plus and minus, so we're going to go ahead and leave this turned off and retain the up, down, and right, left for our elevation and windage. The next option is the distance step size. This simply is telling you whether you want to have this in 1 yard increments, 5 yard increments, 25, 50, 75, or 100. At the bottom of the Solutions tab, there's a slider that allows you to move it back and forth to select the distance that you want to have a shooting solution for. This is simply deciding how broad that is or how big the increments are between each line on that slider. We'll go ahead and leave it at 100 yards because in our classes, we'll generally be shooting 100, 200, 300, and so on. The next option is whether you'd like the app to keep the screen of your iPhone turned on while the app is open. The reason they've added this is, as you can imagine, if you use the app to pull in a shooting solution, you input that in your rifle, you go ahead and engage a target with your rifle. By the time you go back to look at the next shooting solution for the next shot, your iPhone will likely have gone to sleep or have locked, and you're going to have to unlock it, which may require you to break position, etc. So you have the option of turning this on, and effectively your iPhone screen will stay on anytime the app is open, and therefore you'll have that dope with you all the time. Keep in mind though that if the screen is always on, then your battery is going to get used up much more quickly. And then the last option here is just the output precision. So in the shot solution, it's going to tell you either in minutes or in mils what the shot solution is. Because we're in mils, the smallest increment that we could have would be tenths. But if you were doing things like holding wind or even holding elevation, it might be worthwhile to know that it's not just 1.1 mils, but it's maybe 1.15 mils, because then you might hold a little bit in between those two markings. So it's up to you whether you want to get down to the hundredth or whether you want to stay in tenths, or simply just use the nearest dial on the scope and have it round up. For our purposes, we'll just leave it as tenths. The next section is the trajectory table, which again is another one of the display options that you'll get when you hit calculate in the app. This simply shows you all the different shooting solutions for all the distances on an entire table. So for example, if you had 100-yard increments, it would be 100, 200, 300, and so on. The first option in this section is whether you want to show all the data inputs above the table. So what I like about turning this on is that when I'm looking at my drop chart, if any of the data looks suspect, I can look up above and it will show me all my rifle data, like my twist rate, etc., all my ammunition data, like my BC, my muzzle velocity. Then it'll show the target data, like angles, distance to the target, etc. And then at the bottom will show all the weather data. So it simply puts all that information right above the table on the screen, so you can quick reference it if you like. I like that, so I will turn Show Data Inputs on. The next option is by default on that table, it's going to show you multiple columns. The first column is the distance to your target. The second column is your drop in minutes or mils. And the next column will be your drop in inches or feet, which is called your linear path. And then you'll have your wind in mils or minutes, and then you'll have your windage in inches. If you turn this on, it will hide both of those columns where it's showing drop in inches and wind in inches. I recommend turning that on for my students simply to make the table a little more simple and have fewer numbers to look at. Because if you were to mistakenly take the inches of drop and put that into your scope as if it was mils of drop, it's going to be wildly off course. So I would recommend turning this on and hiding those two columns. The next option, similar to shot solution, is just going to choose the step size, but this becomes a lot more important on the table because again, you're going to be viewing the entire table all in one view. If you're shooting in our class, you'll want to simply pick 100-yard increments because all the targets are at 100, 200, 300, 400, and so on, and so your table will reflect that. If, however, you are shooting, say, a rimfire rifle or an air gun, you might want to choose something like 5-yard increments because the difference in 10 yards with an air gun is going to be dramatic, whereas with a centerfire, it's not. So for our purposes, again, we'll choose 100 yards. And then the last one is simply whether you want to sort that table from the highest distance down to the lowest or the lowest distance down to the highest. So 1,000 yards down to 100 yards or starting with 100 yards down to 1,000. That's totally your personal preference. And those are the settings. Now that we have the settings of the app configured, the first thing we'll want to do is click on Firearm and build our first firearms profile. Now when this screen comes up on your phone, it should be blank because you don't have any profiles created yet, but you'll notice that I have a whole bunch. What you'll want to do is click on this plus sign in the top right-hand corner, and that will allow you to build your first profile. Before I do that, I want to show you that the way these are listed and ranked is by the profile name. So if you want all of your 6.5 Creedmoor rifles to be listed or named here together, then you'd want to have the profile names all start with 6.5 Creedmoor. Let's go ahead and hit that plus sign. Now that we have a new firearm profile open, we can go ahead and give it a name. I like all my 6.5 Creeds to be listed together, so I'll list it 6.5 Creed first. Then I'll describe exactly which rifle that is, and I'll indicate that this is a demo. The first bit of firearms data that it's going to ask for is the twist rate of the barrel. Now, the easiest way to get the twist rate is to simply look on the side of the barrel where the caliber is engraved, and you should also have the twist rate engraved there as well. Most 6.5 Creedmoors are going to be a 1 in 8 twist, meaning that the bullet is going to make one full rotation in 8 inches of barrel. It also could be a 1 7.5 twist, which would be slightly faster, meaning that that barrel is going to take 7.5 inches to make that bullet make one full rotation. If you're not sure what your barrel twist rate is, there are some things you can do with a cleaning rod to insert it, make a line in the cleaning rod, push it until it makes one full rotation, and then measure how much cleaning rod it took to get there. And that's going to give you a good idea of what that barrel twist rate is. You can also look it up on your manufacturer's website or call your gunsmith. There's a half decent chance they'll be able to tell you exactly what it is. But keep in mind that it can vary. You could buy the same rifle but have a varmint version that has a very slow twist rate for shooting short bullets. You could buy a long-range version that's more accustomed to shooting long bullets and has a faster twist rate. But it's very important to know what that twist rate is. In class, we'll talk extensively about why a twist rate is so important and how you can use that to determine the optimal bullet that you will want to use for long-range shooting. For example, in long range, we want to shoot the longest, skinniest, highest BC bullet that we can get. But keep in mind that the longer the bullet is, the more challenging it is to stabilize. And oftentimes the key to stabilization is going to be spinning it faster. So the longer the bullet you shoot, the faster you're going to want to spin it. Also, your environmental conditions will also factor in. Here in Utah, we're at a very high altitude. We generally have very thin air and low air density. Therefore, we can get away with a lot more than you can at low elevation, especially if you're at low elevation and cold temperatures where you get very thick air. Again, we'll talk about that extensively in class. Now, as the twist is, you also have a twist direction. I've never seen a barrel that wasn't a right-hand twist, so I would select right-hand twist. The next data input is going to be sight height. Sight height is a measurement from the middle of your barrel to the middle of your scope. There's a few ways to measure this. One would be to take the diameter of your scope, divide it by 2. Take the diameter of your barrel, divide it by 2, and then simply measure the distance between the underside of the scope and the top side of the barrel. Add all those together, and it'll give you your sight height. A more rudimentary way to do it would be to simply take a tape measure or some calipers and line them up on the side of the scope, put one end close to the center of the scope, the other end in the middle of the barrel, and do that measurement. In most cases, this is going to range anywhere from 1.75 inches to maybe 3 inches. With the vast majority of scopes being somewhere in the neighborhood of 2 inches or 2.25 inches. If you really want to be rudimentary about it and you're in the field, you have no other choice. Another option would be to use your fingers. Most people's fingers are roughly 3/4 to 1 inch wide. So if you had 2 fingers, you'd know you got 2 inches, 3 fingers, 3 inches, and so on. That's a really rough way to do it if you have no other choice. Now, if sight height is measured from the middle of the barrel to the middle of the scope vertically, sight offset is the same measurement, but from left to right. Now, you're probably asking yourself, why would my scope ever not be directly above my barrel? And you're absolutely right. It's very uncommon to have a scope that is not mounted directly above the barrel, in which case you would have this sight offset number be 0. But in some cases, if you had, say, an AK-47 Dragunov, where the scope is actually mounted off to the side, or if you have a peep sight that is mounted off to the side, then you would want to input the left and right measurement component of that. For our purposes, we're going to leave that as 0. Now, the next section is describing the adjustments of your scope. Now, most scopes are going to be in either minutes of angle, meaning MOA, or in mils. If you have a scope in minutes of angle, generally each click of the turret, whether it's windage or elevation, is going to be 1/4 minute of angle per click, meaning it takes 4 clicks to get 1 full minute of angle. If your scope is in mils, it's generally going to be in 1/10 clicks, meaning you need 10 clicks to get 1 mil. The middle one there is actually inches per 100 yards, and I've never had a scope to have that particular kind of increment. Maybe one Swarovski that had a weird BDC style turret on it, but generally we never see those. So if your scope is in minutes of angle, it's very likely that each click value is worth 1/4 click or 1/4 minute of angle. If you have a scope in mils, it will be 1/10 of a mil, and you probably will not find one that has inches per 100 yards. All of our rental rifles are mils, so you'll want to select mils. The next one here is where you select what each click is worth. Again, this is a mil scope on our rental rifles, and they are in 1/10 mils. Keep in mind, though, that there are scopes out there that are 1/20th mil or 1/8 minute of angle or half minute of angle, but they are very rare, especially if it is a scope designed for long-range shooting. So again, if you have a rental, you're going to want to pick mils and 1/10, and then your windage unit should be the same. If your elevation unit's in mils, your windage unit should be the same, which would also be in tenths. And then if you're shooting moving targets, you would want your lead to also be in mils. So to recap, if you have a rental rifle, your elevation unit should be mils, elevation gradient is in tenths, windage should be mils, windage gradient should be tenths, and your lead should be tenths. Now this last section is one that you're probably never going to use. When this has 1-to-1, it's essentially saying that your scope is mechanically perfect. When you dial 1 mil, you're actually getting exactly 1 mil. But if you really looked at it under a microscope and did some very elaborate testing, you might find that when you dial 1 mil, you're not actually getting exactly 1 mil. You might be getting 0.96 of a mil or 0.98 of a mil, and there is a little bit of mechanical error there. This allows you to correct for that error, but I've never met someone who actually did the testing to figure this out and actually use it, so we're going to leave it as a 1-to-1 ratio. If we click save, we will have now saved that profile, and you'll see here it's popped up. Once I click on that, it's going to select it as my firearms profile and allow me to create an ammunition profile. Now that we have our rifle profile created and selected, the next thing we'll need to do is create an ammunition profile. Now for each rifle profile, you're going to have multiple ammunition profiles if you would like. There are two ways to build this profile. You can either do it manually, or you can use their bullet library. I'm going to show you both options, but I'm going to start with the bullet library. For our rental rifles, if you follow exactly what I'm about to do, when I go through and enter it in manually, you'll have the best data possible for the class. So this first time through using the bullet library is just an example. What I would like you to do with your rental is use the multiple BC example that I will finish with during this example. So let's go ahead and select bullet library. So in the bullet library, the first thing you want to do before you select anything is come up here in the top right-hand corner and hit this download button. This is going to update this bullet library with the latest and greatest data about these bullets. The next thing you want to do is come down and select the diameter or caliber of your bullet. These are all in inches, whereas they also correspond to the same thing in millimeters. So a .264 caliber is the same as a 6.5 Creedmoor, which would be this one right here. Once you open this, you're going to have the opportunity to scroll down the different letters to find the make of the bullet. So we've got Barnes, Berger, and then down here is where Hornady is. And what we're going to want to look for is the 140 grain ELD match. So if we click on that, it's now going to ask us, do we want to use a G1 BC or a G7 BC drag model? There is also a third model called a custom drag model that is not available in Shooter, that is available in other apps like Applied Ballistics. The G1 model is based off of a very short, fat bullet, kind of like you would shoot out of a handgun or out of a .22. So you're modeling a really sexy long-range bullet against a short, fat, unsexy bullet. It's not a good comparison and won't give you a good prediction. You can do it, it does work, but it's not going to be nearly as accurate as modeling a long-range bullet against another long-range bullet model. The G7 model is a long-range bullet model, meaning a long, skinny, boat tail pointed bullet. So we're going to select the G7, and it's going to auto-populate several different things about that bullet. It's going to first give us the name, it's going to give us the diameter, the bullet weight, and it's got a spot for bullet length. The bullet length is incredibly important because without bullet length, you will not be able to predict or calculate spin drift. And spin drift can have a significant effect at long distances. So to get the bullet length, what we want to do is go into the Chrome browser of our phone, and we're going to want to search for JBM bullet length list. And for me, it already pops up. So I'm going to click on JBM bullet length list. I'm going to enter into their website, and you'll see here that it has a long list of different brands. If I click on the brand of the bullet that I'm using, and then I'd come over and find the caliber that I want, in this case would be .264. Okay, and then I look at the weight. I'm down here in the 140s. I've got my ELDM right there. I scroll over to the side and I can see that my length is 1.347. sorry, 1.374, this guy right here. So I can then go back to my app and I want to enter in 1.374 as the length of my bullet, and now I can effectively calculate spin drift. If you can't find your bullet on that list, which is very unlikely, you can remove a bullet from your ammunition and then measure that bullet and get the same thing. The next data point we need is the muzzle velocity of the ammunition. Now, they do publish the muzzle velocity if you're using factory ammo. They will publish that on the box. The problem with that is it's not often terribly accurate because muzzle velocity can vary dramatically by the length of the barrel used to calculate it or to get it, or the conditions, the temperature of the ammunition, etc. So it can be a good baseline to start out with, and then we can true that as we get out in the field, meaning we can watch what the bullet actually does and how much it drops, and then adjust that as needed using the truing or calibrate function of the app. So for right now, either you know your muzzle velocity because you've used a chronograph, or if you have a rental rifle, it's written on the piece of tape on top of your rental rifle, or you can go to the box of ammo that you use, and that box of ammo should have a muzzle velocity on it. For this 140 grain Hornady match factory ammo, the published muzzle velocity is 2710, so that's what I would enter in there. For atmospheric standard, you're going to want to do the ICAO instead of the ASM. And then the drag model we've already selected as G7. As I mentioned, there is a G1 model, but you always want to use the G7. So based on what we've entered and based on the bullet library, it's now populated our ballistic coefficient for this particular bullet, and it's saying that it has an average ballistic coefficient of 0.305. So at this point, we can go ahead and save this profile and run with that ballistic coefficient. However, one of the nice things about Hornady bullets is they provide a multiple ballistic coefficient sample on their website. So if you go back to Chrome and you simply search ELD BC or ELDX BC or ATIP BC and you search, you don't want to go to the actual page for that bullet. You want to go to the page with all the different ballistic coefficients for all the different Hornady bullets, which would be this one right here. As we scroll down here, it's going to tell us where they're capturing this data. I'll summarize for you with this little diagram that I drew up. So effectively what they're doing, if they only give you one BC, they're more or less taking something in the middle ground. You might remember from the profile that the BC they gave us was 0.305. The BC back here on the Hornady page is going to be different. I have it listed right here. For the first one, it is 0.326, considerably higher than what the bullet library gave us. The second one is 0.320, and the third one is 310, all of which are higher than what the bullet library gave us. So what that effectively means is rather than just taking one single sampling of the life of that bullet, as you can imagine, that bullet will start out going faster and having a higher BC, and then as it slows down, it's going to develop more drag, and it's eventually going to lose stability, and the BC is going to go way down. So by entering multiple BCs, we're doing a better job of describing the true trajectory of the bullet and its behavior as that BC degrades over distance and over speed. So on this card, you can see here, I've got the first BC is captured at Mach 2.25, which the equivalent of that is 2,512 feet per second, which happens around 200 yards. The next one is Mach 2.0, which the corresponding feet per second would be 2233. And the last one is done at roughly 600, 650 yards, where it gets down to 1,954 feet per second, and the measured BC is 0.310. If you're wondering where I got all those numbers, they're right here on the Hornady website. You can see Mach 2.25 is 2512, Mach 2.0 is 2233, and Mach 1.75 is 1954. From there, you can scroll down and you can find your particular bullet. In this case, that one right there. There's our 6.5 Creedmoor Hornady match, G7 BC of 0.326, 0.326. G7 BC of 0.320, 320. G7BC of 310, 310. So you can see that this information is going to give us a much more complete picture of what that bullet is doing downrange. So rather than using what's in the bullet library for our rental rifles, and if for any of you that are using a Hornady bullet, I would encourage you to go to that website and enter in multiple BCs. And I'll do that now. So 0.326, and the velocity for that was 2512. The next one is 0.320, and that one would be at 2233 feet per second. The last one is 0.310. And one interesting thing here is if we were to take and punch in 1954 and try to save this, it's going to give us an error. The reason is we've described what the bullet has done from here to here, from here to here, and here to here. But what about all this? Eventually the bullet's going to go all the way down to 0 feet per second, and we want to know what that behavior is going to look like. So it always asks you to have at least one ballistic coefficient that goes to 0. In fact, when we had the 0.305 originally that the bullet library gave us, you'll notice that the minimum muzzle velocity was at 0. So we do need to have one of these at 0. You can either turn the 1954 to 0, or you can go in and enter in another option at 0.310 and have that one be to 0. Now it would allow us to save it if I clicked save. Before I move on, there's a couple of other things in here that you're not going to use, but I want to describe what they are so that you're not confused. This section is an optional area where you can document the ammo's powder temperature in order to adjust for changes based on temperature. So to do this, you would basically take a sampling of your ammo and make it very cold by putting it like in a cooler in a plastic bag. Take another sample of ammo, put it on the bench at ambient temperature, put another one like on the hood of your car, get it nice and warm, and then go and shoot those different bags of ammo across your chronograph and then document what the speed was for those different temperature and velocity variations, and then enter that into the app. What that's going to do is it's going to take your 0 atmospheric conditions and then the temperature of the ammunition and the temperature of the day you're shooting and try to smooth out the numbers and find kind of the average. I've never bothered to do that. It's a lot of monkey business in my opinion and just isn't really worth doing, but that is what this section is about. So you can ignore that. The next section though is important. This is determining where you have zeroed this ammunition. Now for our purposes, you're going to want to zero at 100 yards. The reason we do that is almost anywhere you go shooting range wise, they're going to have at least a 100-yard range, and that's a really good baseline to start off from. If you put in 100 yards, that means you have zeroed the rifle at 100 yards. Now the 0 height and 0 offset, that would be if your grouping is not dead center bullseye up and down and left and right. So for example, if you zeroed at 100 yards, but your grouping was a 1/4 inch high, then you could come in here and say 0.25, indicating that your 0 was actually a 1/4 inch higher than bullseye at 100 yards. And same thing if it's left and right. It's simply allowing you to correct for any potential error in how things worked out when you zeroed the gun. So for our purposes right now, we're going to assume that everything was perfect. The next option is whether you want to use a 0 atmosphere or not. Again, you don't need to do this unless you're going to be doing the powder temperature and velocity variation portion of the app, which I wouldn't worry about. So in this case, I wouldn't bother using 0 atmosphere. But if you wanted to, what you're going to do is capture your weather conditions at the time that you zeroed the gun, and you'd enter that in here and then save it with that. And then it has a baseline to go off of if your ammunition happens to be hotter or colder. So again, we'll leave that turned off. So in review, if you're going to rent a rifle for class, you're going to be using the 140 grain ELDM factory ammo. Your diameter is 0.264. Your bullet weight is 140. Your bullet length is 1.374. Your starting muzzle velocity will be 2710. But when you get your rental rifle, you can look at the piece of tape on top of the scope to see what the last class's speed was. You'll also have the ability to shoot the rifle across the chronograph on Friday afternoon at class to get your up-to-date muzzle velocity. You'll want to shoot 3 to 5 rounds across the chronograph to get a good average, and that was what you would enter here as your average muzzle velocity. Again, your atmospheric standard is ICAO, drag model is G7, and these are the ballistic coefficients that you would use for this bullet: 0.326 at 2512, 0.320 at 2233, 0.310 at 1954, and 0.310 at 0. And down here, your zero range would be 100 yards. That's assuming that you hit a perfect bullseye. If it is up or down or left or right of that, you can input how much, but generally speaking, we don't worry about that. So now that we have all that captured, we can go ahead and hit save. Now we've got our ammo profile built. We can select that ammo profile. You'll notice now that we have the rifle profile built, the ammunition profile built, and we can start describing our target and pulling in our weather. Let's go ahead and do that. So for the purposes of this first example, I'm going to go ahead and enter in here 1,000 yards. You do have this calculate button where it allows you to use your reticle. If you don't have a rangefinder, you can measure the target size in inches or use your reticle and use that to determine what the range is. So it's kind of a cool little feature. Not something that most people are going to use, but it is kind of neat that you can do that. The next one is important. This is your look angle, meaning what angle are you pointed with the rifle? Are you shooting uphill or are you shooting downhill? So you can use this by hitting the get button, and it will open up the camera, and you'll actually be able to point the camera at your target, and it'll give you your up and down look angle. So you can simply capture that. For our purposes, when we're in class, you're going to be shooting on a flat range, so your look angle would be 0. The next option you have is the speed, meaning if you are shooting a moving target, you'd be able to enter in the speed of that moving target and whether it's coming from the left or the right. And this would effectively give you the lead that you would need to have out in front of that target in order to engage it effectively. Again, in the intro class, we are not fancy enough to be shooting moving targets, so we're going to leave the speed at 0. The next option you have is Coriolis effect. If you turn Coriolis effect on, you can then hit this little arrow button and it's going to capture your latitude. And then the azimuth, if you hit get, again, you're going to get that screen with the camera where you can point the camera at the target. And it's not only going to give you the look angle, but it's also going to give you your azimuth and your latitude. So for our purposes, we're not going to worry about Coriolis. It does have some effect at 1,000 yards, depending on where you are between the North Pole and the equator. It can have up to 3, 4, 5, 6 inches of difference, but where we're shooting in our classes, it's not going to make a whole lot of difference, so we're going to go ahead and leave that turned off. But if you wanted to use it, you simply turn it on, pull in your latitude, hit get, point the phone at the target, capture it, and it'll effectively calculate both left, right, and up-down changes that occur because of the spin of the Earth. All right, the next section is the atmosphere section. So this is saying what are the conditions of the shooting range where you're at right now before you get started. In the previous version of the app, you could simply click a little cloud button in the top left-hand corner and it would populate this data for you. Unfortunately, in the most recent version of this, I don't know why they did it, it doesn't have that button anymore. So we'll actually have to hit calculate and go to the first screen, and it allows us to pull in the weather there. I'm going to do that in just a second. Before I do, the last section here is our spin drift section. If you're not seeing this in your app as you're setting up the app, it's because you don't yet have the length of the bullet inputted in your ammunition profile, because it cannot calculate spin drift unless it knows the length of the bullet and also the twist rate of your barrel. Spin drift is a function of the length of the bullet, the twist rate of the barrel, and the conditions you're shooting in. So for our purposes, we can turn that on. Spin drift generally doesn't have any effect until about 400, 500, 600 yards, somewhere in there, where it's going to be about 1/10 of a mil. So it's not a lot, but once you get out to 1,000, a mile, etc., it can have several inches of drift. So we'll leave that turned on. The only piece that we're missing here is the atmospheric piece, which again, we simply hit calculate. It's going to take us to our first display, which is the solution display. You might remember that in the settings of the phone, this is what we set as our default view. So it's the first one that we're going to see. To pull in the weather, we can simply hit this little cloud and sun icon in the top right-hand corner. Again, it's going to present us with those 3 different atmospheric acquisition options. So we can either use a weather station, meaning it's going to take the GPS location where we are standing and find the closest weather station on the internet that's feeding data to the internet and pull weather from that station. So that's the one that we're going to use today. Know that you can also Bluetooth to a Kestrel or a weather flow meter and pull in data from that Kestrel, and you can actually set it up to continually be pulling data from those devices as well. So if we hit station, we should see this section populate. You can see atmosphere acquired. If we click on that, we can see our barometric pressure is 30.0, altitude's 5106, temperature's 54, humidity's 40. We can adjust these if we want to. We also have the ability to turn the pressure to being absolute. If I do that, it's going to get rid of altitude because we're only taking a pressure reading. We're not doing barometric pressure. So barometric pressure is a corrected pressure. It's corrected based on the altitude that you're at. So it's all basically based off of a reading taken at sea level. If we turn on absolute pressure, that allows us to collect what we call station pressure. Station pressure is actual air pressure at your location and is what the bullet is actually flying through. When you use barometric pressure and altitude, meaning you turn this off, when you use barometric pressure and altitude, the app has to estimate the station pressure using a standard atmospheric assumption, which can introduce some small error. In your weather meter, if your weather meter provides station pressure, it's the most direct and accurate input to use. So if you have a Kestrel or a weather flow and you can pull in the actual absolute pressure, which would be much lower than 30.0, it'd probably be 26 or 27, that's going to be slightly better than using barometric pressure and altitude. But in the app, if you use the weather station and pull the weather from the internet, it's just going to use barometric pressure and altitude. Okay, so if we go back, you'll notice that all of this is populated. It does give us the option for 2 different wind speeds. As you might imagine, wind never stays the same. It changes constantly. So you might want to set a second wind speed of, say, 10 miles an hour. One thing you'll notice, though, is that whatever the dope is for 5 miles an hour, if you take and double that dope, guess what you get? 10 mile an hour dope. So oftentimes it's best practice to take and choose 2 different wind speeds because you can always double 5 to get 10 and double 7 to get 14. And then your wind angle you can change here, or you can take and you open up this dial and change the wind direction, 3 o'clock wind, for example. So all that can be edited there. So now that we have our rifle profile, our ammunition profile, we have our target described, we've pulled in our weather, now we're actually getting into the shooting solution that the app is giving us and what we'll need to enter into our rifle to make a shot. The first screen we're looking at is the solutions display. That's what we've set as our default, our first screen we want to see. You'll notice at the bottom that it has a slider. Currently it's set at 1,000 yards. And up at the top, it's giving us the muzzle velocity at 1,000 yards, the remaining energy at 1,000 yards, and the time of flight at 1,000 yards. At the top left in blue, it's giving us the elevation correction. This is what you'll dial in the top turret of your scope to make that shot and compensate for the drop of the bullet. The next one here is your windage. You might remember we entered in 2 different winds. We have 5 miles an hour and 7 miles an hour, and the wind angle is from 3 o'clock. So if we have a 5 mile an hour wind at 1,000 yards in these conditions with this bullet and this rifle, we need to hold or dial 0.6 of a mil, so 0.6 of a mil, 6 clicks to the right to compensate for that wind. If we have a 7 mile per hour wind, we would hold 0.9 or dial 0.9 to compensate for that wind. And of course, if you want to, you can change these on the fly to whatever you would like, and it's going to update here. The green here is lead. Again, we're not going to be shooting any moving targets, but if you did know the move speed, you'd be able to punch in the move speed and move direction, and it would give you your lead. The other neat thing about the app is it'll actually help you calculate that lead. If we come back up here to speed, you can actually use this to calculate how fast the target is moving. I won't get into that because it's fairly advanced. Down here at the bottom, you've got your Coriolis effect. If you want to turn that on or turn that off or change your latitude, you've got, again, your target speed, target direction, target angle. And then down at the bottom, we can take and scroll this to 900 yards. Now we have our elevation and windage for 900 yards. We can scroll it for 800 yards. We've got all of our data. It also updates our velocity at target, our energy at target, and our time of flight at target. So that is the solutions display. We also can move this up and even go out to like a mile. You also can click on it and type in the distance. So your mile shot is going to require 22 mils of elevation. 5-mile-an-hour wind is going to be 1.2 mils. 10-mile-per-hour wind is 3 mils. And of course, that also is factoring in spin drift. So that's the solution display. Top right-hand corner, you do have the ability to change this to a field view. This is going to be a little bit different. It's going to give you your elevation, your windage 1, windage 2, and then you can simply scroll to change these on the fly. Change your wind speed, wind direction, and again, it's going to give you the solution for that one single shot. Now the next view is going to be my table view. This is oftentimes the view that we recommend people use in our class because we're going to be shooting at 100-yard increments from 100 out to 1,000. So on the left, you're going to see the distance to the target. The next is your drop in mils. The next is your drift in mils. Then you have your velocity, your energy, and time of flight. So it's all the same information that you're going to get from here or from the advanced mode. It's just doing it in a format of a table. You might remember in the settings I mentioned the Show Data Inputs option. I have that turned on, which is why up here above the table I can see the barrel twist rate, sight height, sight offset, etc. I can see my bullet information, my atmospheric information, and my shot data. So that way, if I'm looking at this information, it doesn't look quite right, I can quickly reference all the inputs up here and make corrections as I need to. Now you will notice down here, once we get to 1,700, 1,800 yards, that our velocity turns red. The reason that is, that's showing us when our bullet is going to go transonic and go from being supersonic to subsonic. That does change based on the temperature that you are at. The colder it is, the lower the speed to go transonic. The hotter it is, the higher the speed because the air is thinner. So in this case today it's fairly cold, so at 1,060 feet per second is where that bullet's going to go back through the sound barrier and go subsonic. So it's important to know that because as it does that, you can start to lose stability. But generally speaking, a 6.5 Creedmoor in one of our classes is going to perform extremely well, even out to a mile. Again, here you've got elevation correction for a mile. You've got your drift in mils for a mile for your 5-mile-an-hour and 10-mile-an-hour wind. You've got your muzzle or your velocity of the bullet when it hits the target, the energy at the target, and the amount of time it takes to hit the target. Interesting thing here, nearly a mile away, we're still hitting with as much energy with a 6.5 Creedmoor as a 9mm does point blank, roughly 350 foot-pounds. Pretty wild. So this option up here allows you to be able to share this, so you can email it to somebody by simply clicking the box with the arrow. You also have the ability here to hide the inputs or not, so that would be the inches and feet. You can also show the lead instead of showing the wind. And then the last display option you have is the target card. So the target card allows you to create multiple different ranges, different cards, and then you would simply choose to add a target. So you would say maybe the diamond at 621 yards, and we'll say that it's straight in front of us and it's flat land, save, and then we can go in and enter in another target and do the circle at 857 yards, and the look angle's the same. So you're basically building out a target card that represents what you're seeing on the range, and then it's going to give you your elevation and windage correction for that target. Wow, 5,000 yards, that's a wild one. So you can also edit these. Not sure how that got to be so far. But you get the idea. You can build out a target card for a range that has very random target distances and have all those here in one screen. Now the final section of the Shooter app is this Calibrate section, also known as truing. Truing is a process of adjusting your ballistic solver so that the predicted elevation matches a confirmed impact at distance. When you first build a profile in Shooter, the app will calculate a firing solution based on your inputs, and most of the time it is very close, if not spot on. If it is not, we can use the Calibrate section of the app, also called truing, to correct for small differences between the model and the real world. typically by adjusting the muzzle velocity. Before truing anything, it's critical that all key inputs are correct, including target distance, atmospheric data like BC and muzzle velocity, and rifle data such as twist rate and sight height. Truing should be done once, at a solid mid-range distance, ideally around 600 to 700 yards, where velocity errors show up clearly, but the bullet is still in stable flight. Truing too close, too far, or too often doesn't remove error, it redistributes it and can actually make your data worse. The correct process is simple. Shoot, observe the vertical miss, measure the actual correction required to hit dead center, and enter that value into the Calibrate tool so Shooter can adjust the muzzle velocity and tighten up your entire solution. So let me show you how you do that. If we go back to the solution page and we enter in a distance of 600 or 700 yards, in this case 700, we can see that our elevation correction is 4.6 mils. So we would then dial in 4.6 mils in our rifle, aim center, fire our shot. At that point, let's pretend that that bullet actually impacts low on the target. We would then want to measure from where we aimed to where the impact actually hit, and then take that and add it to whatever we dialed. So let's pretend that that bullet landed 0.3 mils, 3/10 low, meaning that we would then want to punch in a dope of 4.9 mils and fire the shot again. When we do that, if we hit dead center, we'd want to repeat that a couple more times and make sure that that is a good concrete elevation correction for that distance to hit dead center. So now that we know that our dope should actually be 4.9 mils, we can come into the Calibrate section and simply enter in 700 yards, and the actual dope it took was 4.9 mils. And if we calculate, we can see here that our original muzzle velocity was 2710, but the new muzzle velocity based on the drop of our bullet is 2643. So at this point, we can choose to use that muzzle velocity by clicking this blue button. That will effectively replace what we entered in our ammunition profile with this new number, or we can ignore it. If we really want to true up our data and calibrate our app to be as accurate as possible, we would want to hit Use Muzzle Velocity. And now when we go back to our solution, we should see that the elevation should match up to the corrected elevation that we actually saw hit the target. So that is how you would use the Calibrate section of the app. Now that we've calibrated the ballistics app for our 700-yard shot and it's giving us a proper 4.9 mils of elevation, I want to show you how you would dial that into the scope. So you'd come here to elevation turret. This is what's going to move the reticle up and down. Right now we're set at 0, which would be our 100-yard shot. And if we want to dial to 4.9 mils, we would come over here to 1, 2, 3, 4. That would be 4.5. That's 5. 1 before 5 would be 4.9 mils. And then for windage, we recommend that you hold the wind within the reticle. So you'd use the hashes on the reticle to tell you how far left or right you would want to hold it. In this case, we have a 5-mile-an-hour wind coming from 3 o'clock. That we would hold 0.5 mil for, which is not very much at all. If you were going to dial for it, you'd do that here on the windage turret. And again, this is a wind coming from the right to the left. So we would dial to the right, meaning we'd come back towards us, and we'd come back until we hit the 0.5. And that's what you would do if you were going to dial for that wind and for the elevation. So now using the target card view, we're going to show you how you would dial for targets at 300 and 100 increments out to 1,000 yards. So let's start out with 300. So the dope for our 300 yards is 1.2 mils. So we depress the lock, come down here to 1, and then 2 clicks beyond that would be 1.2 mils. We'd fire our shot. The next would be 400 yards, which is going to be 2 mils. So we dial to 2 mils, fire our shot. 500 yards is 2.9 mils, so there's 2.5, there's 3, 1 before that would be 2.9. For 600 yards, you'd be 3.8 mils, so we'd come to 4, come back 2, that would be 3.8. The next one is 4.9, so it'd be just barely before 5. 800 yards would be 6 mils, that's easy, we go straight to 6. And then 900 yards would be 7.3 mils, so we'd go to 7, and then 1, 2, 3 past that would be 7.3, and 1,000 yards would be 8.6 mils, so we'd go 8, 8.5, 1 past 8.5, that would be 8.6 mils. Before we wrap up the video, I thought I'd take a moment and just discuss how to hold for wind. This is always something that gets very confusing for some folks when they come through our classes the first time, but once the light bulb comes on, it becomes very simple, and there's some basic concepts that you can apply that will really help you be effective at holding for wind. Again, you have two options for compensating for wind. You can use the turrets of the scope to dial for the wind just like you do for elevation. However, the inherent problem with that is oftentimes the wind is changing so rapidly and so often that by the time you make the correction and you dial in the correction into your scope, you get back on the rifle to take your shot, the wind has changed. And so you're gonna have to break position, change it again, and by the time you get back on the gun, it's changed again. So a lot of times, unless you have a very consistent wind, your best bet is to hold for wind using the markings on the reticle, meaning you're doing the same compensation, but you're simply holding the reticle to the left or the right to compensate for the wind that you're observing, which allows you to, one, it's much more intuitive. You can generally go, okay, if the wind's blowing from left to right, I need to aim to the left because the wind's going to blow the bullet to the right. So it's more intuitive, and it's also a lot faster, and you can also adjust it more quickly as you see those changes. So a couple things to remember. Always aim your crosshairs into the wind, because that wind is going to push the bullet back the other direction, right? If it's blowing from left to right, you aim into the wind, meaning you aim the crosshair to the left. If you always remember that, knowing which side to use for your measurements is very easy. So always think in terms of the center crosshair and moving that center crosshair into the direction the wind is blowing. So again, in this case, we have a left to right wind, move the crosshair to the left and use the markings on the downwind side on the right to know how much to hold. So the example I'm showing here again is a 9 o'clock wind blowing left to right. Would you put the letter A on the center of the target, or would you put the letter B in the center of the target? So think about that for a second, and I'll give you the answer. All right, drum roll. Here the answer is, it's B. So again, if we have a wind blowing from left to right, you'd push the crosshair into the wind, against the wind, because that wind is going to blow the bullet back to the right. So the markings you would use to know how far to push the reticle to the left, those markings would reside on the right-hand side of the crosshair. In this case, where we have the B would be 1 mil, and we want to hold 1 mil of left wind, which means we're pushing the reticle to the left. Now, if we were to dial on the turret, one pro tip is remember the phrase, I'm going to be right back. Because when you dial the turret back towards you, meaning counterclockwise, you're moving the bullet to the right. And if you're pushing it forward, you're pushing it left, meaning you're pushing the bullet to the left. So for this particular shot, if we had the wind blowing from left to right, we'd want to move the bullet to the left, so we would push forward 1 mil. Whereas if it was blowing the opposite direction, blowing right to left, we would want to move the bullet or move the turret to the right, and that would be pulling it back towards us 1 mil. Well, we want to thank you for joining us today for this video on how to set up and utilize the Shooter Ballistics app. If you're already signed up for one of our classes, remember to follow the instructions in today's video to the T and try to get your app set up as best you can before you arrive at the class. If you've rented a rifle from us for the class, remember that all the data we used in today's video is based on our rental rifles. If you enter everything exactly the way I did in the app, you should be 95% of the way to having your profile complete for your rental rifle. When you do get to class, we'll assign you the actual individual rifle, and on that we'll have this piece of tape on top that will have all the data about the rifle and ammunition so you can complete setup to 100%. If you aren't signed up for a class yet, but you're interested in learning more about long-range shooting or honing your skills, be sure to check out our website at longrangeshootersofutah.com and look for our course schedule. Do keep in mind that we release classes every year on Thanksgiving Day, and we generally announce our schedule for the following year a few weeks before that. When it does open, our classes sell out extremely fast. In 2026, we released on Thanksgiving, and all of our classes from March through July, which is the bulk of our season, sold out in just 5 days. And as of right now, our entire season will be sold out before our first class even starts. So we do have waiting lists, so if all the classes are sold out, you can join a waiting list for each individual class, and it is common for us to have at least a handful of cancellations prior to a class to give people an opportunity to join. We often will add extra classes throughout the year if things do fill up. So again, be sure to follow us on social media at Long Range Shooters of Utah, subscribe here on YouTube, and check out our website at longrangeshootersofutah.com. and we look forward to seeing you in our next class.
7.9?
Your parallax.
Oh yeah.
Oh, perfect
my
wind.
gosh.
Perfect elevation.
Hey, my name is Bryce Bergen. I'm the founder of Long Range Shooters of Utah and the chief instructor here at our range. We teach an intro to long range class at North Springs Shooting Range in Price, Utah that is one of the most phenomenal facilities in the world, and the class is awesome. We're going to cover heavily the fundamentals of marksmanship, which is going to be a proper position, achieving a natural point of aim, proper breathing, trigger control, and spotting your own shots. This is a great course for somebody that is an absolute beginner, hasn't ever shot a gun before. You can come to this course, have a great time. You can also rent a rifle if you don't have one. We have excellent rental rifles available that give you everything you need, including ammo. You can come out here as an advanced shooter as well and really learn something. A lot of people walk away with some really great ahas, things they've never seen or heard before that can dramatically help your shooting ability and your marksmanship. But like I said, we focus heavily on the fundamentals, and at the end of the class, we guarantee that every student will go home having hit a regular 1-gallon milk jug at 1,000 yards. You also get the chance to come out and shoot a mile after class if you would like to. We just had a couple students hit milk jugs at a mile in an intro to long range class.
Perfect elevation.
If you'd like to come out and join us for one of these awesome intro to long range classes, visit longrangeshootersofutah.com. Check out the class schedule. You can register for classes there. You can also reach out to us at info@longrangeshootersofutah.com.
Get some of that, Jimmy!
Hi everybody, my name is Bryce Bergen. I'm the founder and lead instructor here at Long Range Shooters of Utah. I'd like to personally invite you to come out to our Intro to Long Range class and enjoy this incredible shooting facility that we have here. We have the blessing of shooting at the North Springs Shooting Range, where we can shoot out to a mile any given day. As part of the class, you're going to get the opportunity to attempt our milk jug challenges. In the class itself, every student we guarantee will go home having completed our 1,000-yard milk jug challenge.
So fun and so much improvement, man. It made so much progress. It's incredible.
Bryce helped me out. Hit a jug from a mile away.
In the class itself, we're going to cover the fundamentals of marksmanship heavily. We want to make you as precise as a shooter as you possibly can be and really improve your consistency and maximize the effectiveness of whatever platform you bring to bear. We're also going to take the time to visit with you before class to make sure your equipment is sound, that it's set up and create success for you in this course. From there, when you get into class, we're going to teach you how to use a ballistics app, how to pull in good data and put that data into the app so you get good data out of the app. Sometimes the bullet doesn't do exactly what the solution tells us, so we'll have to true up that data. We'll teach you how to do that as well. In addition, we're going to teach you the wind. We're going to give you a baseline number. We're going to give you how to correct for intensity and also for direction. But most of all, we have an absolutely great time. It's a fun group of people, the instructors are a blast, and the facility is second to none.
Let's go!
So I hope you come join us here at Long Range Shooters of Utah Intro to Long Range.